In class activity 9A, the Pythagorean identity. In this activity, we will study a trigonometric identity based on the Pythagorean theorem. 1. Suppose you have a right triangle in the first quadrant of the unit circle as pictured. Part A, how are the values of sine theta and cosine theta related to the sides of the triangle? Well, the values of sine theta and cosine theta, we could say, are the lengths of the two legs of the triangle. Part B. What does this tell you about sine squared theta plus cosine squared theta? Well, sine squared theta plus cosine squared theta, well, is equal to 1, which is just the Pythagorean theorem. So if we go to the next page, objectives for the activity, you will understand that the Pythagorean identity, sine squared theta plus cosine squared theta is 1, is a restatement of the Pythagorean theorem in terms of sine and cosine. You will be able to prove identities using the Pythagorean identity. Use the Pythagorean identity to determine values of sine and cosine. Well, listed at the top here is the Pythagorean identity. We see it as sine squared plus cosine squared is equal to 1. 2, the Pythagorean identity is very powerful. For example, it allows one to use information about the sine of an angle to deduce information about the cosine of an angle and vice versa. Part A, if you know that the sine of x is equal to 2/3, what does this tell you about cosine of x? Well, we could start, let's draw a quick triangle. Here's our right triangle, and the angle is going to be x here in the corner. We could start by writing the sine squared x plus cosine squared x is equal to 1. Well, we know what the we know what the sine of x is. It's given to us as 2/3. So we could write 2/3, and we're squaring that, plus the cosine squared of x, and it's going to be equal to 1. Well, if we rearrange this as the cosine squared x is equal to, and we put the 2/3, that quantity, that fraction squared on the other side of the fraction, we get 1 minus 4/9, which is just 9 minus 4 over 9 over 5/9. And then if we take the square root of both sides of the equation, we end up with cosine x is equal to the square root of 5 over 9. Part B, what are the possible values of sine of y if you know that the cosine of y is equal to 1/5? I'm going to start the same way. Just going to draw a quick sketch of a right triangle. And our angle is y this time. And hypotenuse is still 1. That's supposed to be 1/5. There we go, 1/5. We know that the cosine of y is 1/5. So I'll start by writing sine squared y plus cosine squared y is equal to 1. So that means that the sine squared y plus, well, we know the cosine is 1/5, and we're going to square it, still equal to 1. Then we have the sine squared y is equal to 1 minus, and putting that 1/5, that fraction to all fractions squared on the other side, we get 1 minus 1 over 25, which is just 24 over 25. Taking the square root of both sides, we get sine of y is equal to 2 square root of 6 over 5. And the screen's not moving. Hold on. Okay, looks like the screen's fixed. And before we go on, let's just do a little bit of work here. The 2 root 6 over 5, you may be wondering where that came from. Well, if we take the square roots, and I'm just going to write on the side here, we have 24 over 25. And if we take the square root of all of that, and we rewrite 24 as 2 cubed times 3, and then we rewrite 25 as 5 squared, we would get, and I'm going to write underneath here, the square root of 2 cubed times 3 over square root of 25. The denominator is 5. That's easy to see. But if we simplify the radical, we're going to end up with the 2, and then 2 times 3 or 6 under the radical. So that's how we get the 2 root 6 over 5. Now on to the next screen. Part 3, because of the Pythagorean identity, expressions involving squares of sines and cosines can often be simplified. Prove the following identities by showing step by step how the left side may be rewritten to look like the right side. Part A says 3 cosine A, that quantity squared, plus 3 sine A, that quantity squared, is equal to 9. So let me just start by writing that. 3 cosine of A, that's all that quantity squared, plus 3 times the sine of A, that quantity squared, is equal to, well, 3 squared is 9, cosine squared of A is cosine squared A, plus 9 sine squared A, which is equal to, if we factor out the 9, we have cosine squared A plus sine squared A, and we get 9 times 1, which is just 9. Let me make that look like a 9. Like a 9. All right, part B. Here we have another identity to prove. What I'm going to do is just start by writing it again. I have 1 plus sine of B squared plus cosine squared B. And we can write that by writing, let's see, if we square this binomial, we get 1 plus 2 sine squared B plus sine B plus sine squared B now. And then we have a plus cosine squared B equals 1 plus 2 sine squared B plus, and we have another here, we have the sine squared plus cosine squared, which is just 1. So we end up with 1 plus 1, which over it is 2, plus 2 sine of B, which is what we wanted to end up with. And that is the end of this video. Thank you.